Hello everyone, Gavin here. In this video, I'm going to walk you through a cybersecurity project where I built and configured a Suricata IDS IPS system in a virtual lab environment. I'll show you how I set up the lab, wrote custom rules, simulated attacks, and captured alerts, all in a hands-on setup. Let's dive in. The goal of the project was to build a working intrusion detection system using Suricata. I used three virtual machines, a Kali Linux attacker, as seen right here, a Windows victim machine, which is in here, and an Ubuntu server that is running Suricata as an IDS. My objectives include writing custom detection rules, simulating attacks, and validating alerts using real-time logging. Each virtual machine was created using VMware Workstation with static IPs. Kali Linux using 192.168.75.134. Windows is using 137, and Suricata is 132. Suricata monitored the ENS33 interface and was configured to log both to fast logs and EVE-JSON. A Python HTTP server ran on the Windows virtual machine to support web-based attack scenarios as seen right here. Now, let's take a deep dive into the custom rules I wrote inside Suricata local rules file. I'll go through each rule line by line so you can see how Suricata interprets malicious traffic. So in the first rule, this is the ICMP ping detection I have. So we have the alert that tells us Suricata to trigger an alert if this rule matches. We get the ICMP protocol being monitored, Internet Control Messaging Protocol. We got our from attacker to target on any port. ICMP doesn't use ports normally. We get the message that appears in the alert logs. We got the I-type 8, which matches ICMP echo requests standard ping. Then we got the unique signature ID right here. And then we got the number of times this has been revised. For the port scan, much like the one above, we have the alerts, which up is still tell Suricata to trigger an alert if the rule matches. Then we got the TCP, which applies only to TCP packets. Flag S in this rule detects SYN packets. Use the initial TCP or the used to initiate a TCP handshake. And threshold type or threshold, which I set to type both, which in this case watches new and ongoing flows. Track by screen monitors by source IP address. Count 10 alerts after 10 matching packets, and seconds at 10, which is within a 10-second window. This is just another SID that doesn't match the prior one because everyone has a unique ID and they can't use the same one. In the SSH brute force detection, we are targeting port 22 for SSH. Flag S again, match only SYN packets. Threshold trigger alerts if 5 connection attempts occur in 10 seconds from the same IP. For the fourth rule, we got the HTTP URL access, so pretty much the passwords, basically, from via websites. HTTP uses Suricata built-in HTTP parser. Flow to server establish in this rule. Packets must be going to the server after TCP handshake. Content etc password string to search for the URL. The HTTP URI restricts the search to HTTP request lines, not headers or body. And for the final rule, we have the suspicious user detection, which searches content SQL map searches for string SQL map. HTTP header restricts the match to HTTP headers. This catches automated scanners that reveal themselves via their user agent string. Each rule targets a specific pattern of attack. Now, let me walk you through how I trigger those rules in my lab environment. To monitor alerts in real time, I use the following command as seen in the below. This command filters EVE-JSON to display only alert events in a great way to see Suricata in action as traffic flows across the network. So, as a demonstration, let's walk through the commands I use to simulate each attack and verify that Suricata responds appropriately. So, as we swap to Kali, we can start with a ping command, for example. This will send down 6 pings to this destination. And when we swap back to our Suricata, you can see that we get ICMP ping detected, which is a demonstration of our first rule. Now, let's look at our second rule, which is our port scan. Sending an mmap command. From this attack, this triggered rule 2 when more than 10 SYN packets hit in a short time frame. Now, with the brute force attack, our third command, it will trigger our third rule. When swapping over here, we will see that now the alert is possible SSH brute force, which is after 5 SYN attempts to port 22, rule 3 was triggered and logged as an alert. So now moving on to the fourth attack, which is our etc password, which is the one that attacks our website because we have Windows running. Now let's send the attack for this one. Attack has been sent. And as seen in here, access to etc password has been flagged. Thus meaning the match the password string and triggered rule 4, mimicking a common detectory transversal pattern. Now for our last attack of this demonstration, we have the SQL map detection. As you can see, the SQL has been sent, and it has been shown here that a suspicious user has been detected. Because SQL map adds its name to the user agent string, Rule 5 successfully caught the automated scanner and fired an alert. Challenges that I faced. So, challenges include Suricata setup issues, rule conflict, and stale rule catching. After realizing that commenting out a rule wasn't enough, I had to clear Suricata cache and restarted the service to fix this issue. Of this project, what I've learned is that this project gave me a better hands-on experience with writing and tuning Suricata rules, packet inspection at multiple protocol layers, log parsing with tools like JQ, and simulating real-world attacks in a controlled lab environment. In my final thoughts, I built a portable IDS lab that can detect and respond to network threats using custom logic that is a solid foundation for threat detection, red team simulation, or security research. Thank you for watching. If you like my rule set and Suricata configuration, then send me a good note.